Hi you guys, welcome back to another video. Today we're going to be reviewing our midterm test, which was over inverses, exponentials, and logarithmic functions. So let's start with number 1. If the domain of f of x is equal to 2x squared minus 1 and is restricted from 0 to infinity, which graph represents the inverse of f of x? So let's do it algebraically first, and then I'll show you some tips to use on the calculator. So the first step is to take your function that they gave you, which was f of x equals all of that. I'm going to rewrite that on the side. Now the first step is to switch f of x for y. The second step is to interchange or switch your x and y values. And then the third step is to solve for y, and you're going to be using PEMDAS upside down. So you're going to start at the bottom and work your way up. So first you're going to see if there's anything you can add or subtract, and I can see that we can add 1 on both sides. So we get x plus 1 equals 2y squared. There's nothing else I can add or subtract, so I'm going to scratch that out. The next thing is multiplication or division. So the 2 is being multiplied by y squared, so I can divide out the 2. And 2 divided by 2 equals 1, so that cancels out. So now I'm left with x plus 1 over 2 is equal to y squared. Okay? So there's nothing else I can multiply or divide, but the next thing is an exponent. Now to get rid of that square, I will have to take the square root of both sides. Okay, so the square root and the square cancel out, and so y is equal to the square root of x plus 1 over 2. Now the square root is usually written without the 2 in the front, but I did want you to know that there is a 2 in the front. It's just the most common, so you don't really have to write the 2, but that is why a square root and a square cancel out. But okay, so remember, anytime you take the square root of a number, you will always have the plus or minus symbol in the front. Now, to determine whether you're going to use the plus or minus symbol, you're going to look at the domain that they gave you. The domain they said was 0 to infinity. That is all of the positive numbers. So you're going to pick the positive square root, not the negative square root, because of that domain restriction. So I'm going to go ahead and get rid of the minus, and I know that it's going to be a positive square root of x plus 1 over 2. Okay, so now what I'm going to do is graph this into the calculator. Okay, and then you can analyze the graph and try to eliminate some options. So what I see here is that it starts at -1. So if you pull up your table, you can see that the very first point is -1, 0. So all of that in the top is undefined because the graph does not exist there. So I'm going to look at my answer choices and see which one starts at -1 and 0. Okay. So -1, 0 would be here. A is incorrect. -1, 0. C is incorrect. -1, 0. B might be an option. -1, 0. D might be an option. So B or D are, our answer choices. So let's look back for some more coordinate points and see what matches. Now the next whole number coordinate point is 1, 1. So I can look to see if there's something at 1, 1. So this one is kind of in the middle, but notice that this one is exactly at 1, 1. So that, lets me know that D will be the correct answer choice. Now let's say that you forgot how to do all of this algebraically. What you can do is graph the original. So I'm going to show you. Whoops. So I'm going to open a new graph. The original question was 2x squared minus 1. Now, if you recall, the inverses on the table, they switch. The coordinate values switch. So if you went to the table of the original one, then you can grab some of these coordinate points and switch the x and the y values. However, you need to be careful that you're only picking the values that are greater than or equal to 0, because in the domain, that's what they said. Okay, So if we're gonna use the table for this, we need to pay attention to the domain and go from 0 to infinity. So let's say I'm gonna use this method. So let's say or, and I'll create a table, and I have to go, past 0. Let's say I do 4 points or something. I keep going to the wrong app. Okay, so at 0, -1. Okay, so -1, 1, 7. -1, 1. I think I messed it up. -1, 1, 7, 17, 31. Okay, so if you're gonna take the inverse, then all you need to do is switch your x and y coordinates. So all the y values become the new x values, and all of the x values become the y values. Okay, and then you can try to match up the coordinate points. So the first one was -1, 0, which that is the first one we tried here, which eliminated A and C. And then the second coordinate point we did try originally was 1, 1, and we talked that this one doesn't touch it, but this one is right at 1, 1. So that's another way that you can do inverse functions. If you forget how to do it by hand, just graph it and pull up the table and switch your x and y coordinates. Okay, let's go to the next problem. Newton's law of cooling models a temperature T of an object over time T in minutes using the function T of T equals T sub m plus T sub 0 minus T sub m times e to the power of -kt, where T sub 0 is the initial temperature of the object, T sub m is the temperature of the surrounding medium, and K is a constant for that particular medium. A cookie was taken from the oven and placed on a cooling rack with a surrounding air temperature of 20 degrees Celsius. After 5 minutes, the cookie cooled to 48 degrees Celsius. If K equals 0.35, what was T sub 0, the initial temperature of the cookie? Okay, so there are a lot of variables here, and so I don't want you to get confused, so I'm going to write them down, literally each one with the meaning of it. Okay, so it starts off with temperature being T. So where I see T, like an uppercase T, is at the beginning of the equation. Now you might be asking, well, why do they have this little t there? Well, that's just telling you what is the temperature after an X amount of time. So little t represents time. So it's just saying, like, after 5 minutes, it'll be 200 degrees. After 10 minutes, it'll be 300 degrees or something like that. So it's a function of time, but big T represents the temperature. Okay. Let's see, let's keep going. The next thing is, okay, so little t is time. That was right here. T is time. We have T sub 0 is the initial temperature. Oops, it's capital T. T sub m is the temperature of the surrounding medium. K is a constant. Now you guys might be thinking, this is so tedious, why do I have to do this? I can read. When there are so many constant like this, and especially with letters that you're not familiar with, it can get kind of confusing. So it's better to just take your time and try to figure out everything that's going on. Okay, so let's see. A cookie was taken from the oven, placed on a cooling rack with a surrounding air temperature of 20 degrees. So surrounding air temperature, which is T sub m, is 20 degrees. After 5 minutes, so little t is 5, the cookie cooled to 48 degrees. So big T, sorry, I cut that off short. The law of cooling is the temperature. So the cooling temperature is big T, and the cookie cooled to 48 degrees. And then K is 0.35, and what we're trying to find is t sub 0. So that's our unknown variable. So I'm going to grab that equation they gave me, and then I'm just going to start plugging in all of the variables that we have. Okay, so big T is 48, T sub M 20, T sub 0 is what we're solving for, we don't know what that is. T sub M again is 20 times E, negative K, which is 0.35, and times T, which is 5. Okay, so you're going to be using PEMDAS upside down again. So you're going to ask yourself, can I add or subtract anything? You can subtract 20 on both sides. 48 minus 20 would be 28. Okay. Now remember that E is just a number. E is 2.71 da 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 whatever. So a number to the power of another number, all of this is just going to be another number. So we have a number being multiplied by this parentheses, by this factor. So to get rid of that, we're going to divide it out. Now I don't want you to try to put this into the calculator straight away, because if you start rounding in the middle of the problem, at the end you're going to have the wrong answer because you rounded in the middle. So you should only ever round at the very end of the problem. Okay, so now we have this fraction, 28 over E negative 0.35 times 5 is equal to T sub 0 minus 20. Okay, so and the last thing would just be to add 20 on both sides. So we have 28 over E negative 0.35 times 5 plus 20 on the outside, and that's equal to T sub 0. So I'm going to put this into the calculator right now. So 28 E to the power of negative 0.35 times 5, and then outside of the fraction will be plus 20. Okay, so we get 181.129. And this is temperature, so it'll be measured in degrees. So in looking at our answer choices, the most obvious choice would be 181 degrees Celsius. Okay, now let's say that you forgot how to do all of this. You have no idea what's going on. All you need to know, the most that you need to know is how to plug the numbers into, go away. Okay, how to plug the numbers into the formula and get it set up. So if you can get to at least this right here, then you can just use NSolve in the calculator. I know I'm not a big advocate of NSolve, but it's okay. So you go to Menu, Algebra, and then NSolve. So in here, you're going to type the equation at exactly how you see it. So 48 equals 20 plus... Now, you're not going to use T sub 0. You're just going to use X in there. Minus 20 times E to the power of negative 0.35 times 5. And then you need to tell the calculator what variable you are trying to solve for. So then you need to put comma, and we're trying to find X, so put X, okay? And all of this needs to be inside of the parentheses. And then you're going to press enter. And notice how we get the same exact answer. So if you forget all of your algebra steps, or if you just want to double check your work, then that is a good solution for you. All right, let's go to the next problem. The formula to calculate the level of sound intensity in decibels is beta equals 10 times log of I over I sub 0. So that B thing is the Greek letter beta. where beta is the number of decibels, I is the sound intensity in watts per square meter of any sound, and I sub 0 equals 10 to the power of negative 12 watts per square meter, which is the intensity of the faintest sound audible to the human ear. The pain threshold for the human ear is 120 decibels. What is the intensity I of this sound? All right, so again, there's a lot of things you probably have never seen before. They're trying to throw you off. They're trying to intimidate you. So just break the problem down, figure out what each variable really means, okay? So they tell us that beta is the number of decibels. I is the sound intensity. Let's see, I sub 0 is 10 to the power of negative 12. Okay, and then we're trying to solve for I. It says that in the question. What is I? So I is going to be the unknown variable. So by process of elimination, and also sound intensity is measured in decibels, and beta is the number of decibels. So it says the decibels, and then that will be beta. So beta will be 120. So let's use the formula they gave us. So beta equals 10 times log I over I sub 0. Okay, so beta is 120 times 10 log I is what we're solving for, and it's divided by 10 to the power of negative 12. Okay, you're going to use PEMDAS. You cannot add or subtract anything, but you can divide out the positive 10. So this 10 and this 10 cancel. 120 divided by 10 is 12. Okay, so now you might be wondering, how am I going to get that I when it's part of the log? Remember that every log that does not have a base means that it does have a base of 10. Okay, so what this becomes is a logarithm function where you're going to convert it into an exponential function by doing the little loop-de-loop. Now we're used to having the constant number on the right hand side, so if it helps you to rewrite it and put the number on the right, you can go ahead and do that, okay? And then so remember, you start with the base and you go to the outside and then you come back into the inside. So what this becomes as an exponential is 10 to the power of 12 is equal to I over 10 to the power of negative 12. Now I is in a fraction, and remember, to get rid of fractions, you're going to multiply by the denominator on both sides. So these two are going to cancel out. Now I is equal to 10 to the power of negative 12 times 10 to the power of positive 12. You may not remember your law of exponents, but if you have two exponents that have the same base, so the base here is 10, what you can do is add the exponents. So we're really just going to do negative 12 plus 12 is equal to I. So because they share the base of 10, you can add the exponent. So it'd be negative 12 plus 12. Now negative 12 plus 12 is 0 because they cancel out. So if you look at your answer choices, you do have 10 to the power of 0 as an option. Okay, so again, let's say you have no idea, you got stuck, I don't know. You can also put this in NSolve. You do need to set it up at least to right here. Like, you need to know how to do all of this before you do anything in NSolve. So let me show you. If we do it in NSolve, that would be 100 and, oops, I gotta put menu, algebra, and then solve. So 120 equals 10 log. If it asked you for the base, there wasn't one originally, but we know that there was an imaginary 10 right there. And again, we're not going to put the letter I, we're just going to put X, and then we know that that's the unknown variable we're solving for. And it was divided by this. Now I'm going to get out of this, and so I'm outside of the log parentheses, but still inside of the end solve parentheses. So that's important because then you're going to do comma x. You need to assign the variable you want the calculator to solve. You're going to press enter. Now it equals 1. You're probably asking yourself, well, that's not what you said it was. That wasn't an answer choice. So what you can do at this step, so let's say you have no idea why the answer choices do not say 1, then what I want you to do is go one by one and try to figure out which one equals 1. So we're going to start by plugging in 10 times 10 to the power of 120. That's obviously wrong. The next one was 10 to the power of 12. That one is obviously wrong. The third option is 10 to the power of 0, and that one gives you 1. So 10 to the power of 0 is 1, and if you do end solve, you get 1. And so that's how you can confirm your answer that way. Okay, let's go to the next problem. The annual growth rate for an investment is found using the function r equals 1 divided by t times the natural log of p divided by p sub 0, where r is the annual growth rate, t is the time in years, p sub 0 is the initial investment, and p is the present value. 5 years ago, Helen invested $5,000 at an annual growth rate of 3.7%. What is the present value of Helen's investment? Okay, so let's see, we have a bunch of different variables. So r being the rate, so they gave us the rate, they said the rate is 3.7. But remember, you have to convert it to a decimal, so you're going to move this over 2 places, so the rate would be 0.037. T is time in years. It says 5 years ago, so T will be 5. P sub 0 is the initial investment. It says she invested $5,000. Okay. And let's see what else. P is the present value. And the question is, what is the present value? So that's the unknown that we're going to solve for. So now using the equation they gave us, r equals 1 over t natural log of p over p sub 0. So plug everything in. 1 over 5 times the natural log p over 5,000. Okay, so you're going to do PEMDAS upside down again. That's not going to change. You can divide out that 1/5. So you can do 0.037 divided by 1/5. Let's go put that in the calculator. 0.035 over 1/5. It's 0.175. Oh, I did it wrong. It was 0.37. My bad. So 0.37 over 1/5 is 0.185. That's equal to the natural log of p over 5,000. Now the natural log is related to the letter e, so they can cancel each other out. So the same way that we use the square root to cancel out a square, or the cube root to cancel out a cube, and these cancel out, the same way that e and natural log cancel out in both directions. So if we want to get something in here, but it still has the natural log in front of it, we have to get rid of the natural log by multiplying both sides of this by the letter e. Okay, so it's going to be times e on both sides, and e times the natural log are going to cancel out. So what you have left is e to the power of 0.185 is equal to p over 5,000. Okay. Now p is in a fraction, so to get rid of that, we're going to multiply both sides by the denominator, which is 5,000. Okay, so now all we're going to put in the calculator is 5,000 times e to the power of 0.185, and we get 6016 with 9 cents. Okay, and let's look at our answer choices. So the correct answer is C. You can use and solve again. So the important thing here is that you know how to read the problem, analyze what each variable represents. So let's see, 0.37 equals 1/5 times the natural log of x. Oops, I messed it all up. X divided by 5,000. And then outside of that, we're gonna do comma x, enter, and we get the same value. Okay, let's go to the next problem. Blake is purchasing a new car for $32,000. If the value of the car decreases at a rate of 9% per year, approximately how many years will it take for the value of the car to reach $15,000? So this is an exponential decay problem. I know that because it says it's decreasing at a rate of 9% per year. So I'm going to look at my formula chart to see if there's a formula for exponential decay. So the exponential decay formulas are on the second page. And so you can see we have the exponential growth or decay right here. So the equation does look a little bit different than what we learned in class. So I'll use the one on the formula chart so that you get kind of familiar with it. So that was n equals n sub 0, 1 plus r to the power of t. Now what we learned in class was just y equals a, 1 plus r to the power of t. So it's very similar, but basically this is the subscript of 0 always tells you your initial value. So that's your starting point. You're starting at 0, and then what are you ending up with? Okay, so it's going to be the same thing. It doesn't matter what formula you use. So let's see, he's purchasing a new car for $32,000. So that's the initial amount of the car. So that's going to be n sub 0. And then we have 1 plus, and then it says the car decreases at a rate of 9%. So remember, 9% as a decimal, you grab the decimal place, move it 2 places to the left. So it'll be 0.09. And we're trying to find years. So time is an unknown variable for the car to reach 15,000. So that's going to be our end result. Okay, so using algebra, you're going to use PEMDAS backwards, nothing to add. Well, yeah, we can add the inside piece actually, inside the parentheses. So it'll be 1.09 in there. And then after that, we can divide out the 32,000. Okay, we can put that in the calculator. 15,000 divided by 32,000 is 15 over 32. A trick that you can actually use to save time is if the amount of zeros match up, you can cancel them out. So this 0 cancels that one, this one, and that one. So that's how you end up with 15 over 32. And that's equal to 1.09 to the power of t. Now, when you're trying to solve for a variable that is raised to a power, meaning it is an exponent, the only way to bring it down is to take the natural log of both sides. And so what that does is grab this power and bring it to the front. So we're going to end up with this. The natural log of 15 over 32 is equal to t times the natural log of 1.09. Now remember, the natural log of a number is still just a number. So to get t by itself, we're going to divide both sides by the natural log of 1.09. This cancels out. We'll put this big fraction in the calculator. Natural log of 15 over 32 divided by the natural log of 1. Oh, I messed up. I added instead of subtracted. Wait, why did I? Oh my gosh, I messed up the whole I am so sorry. Okay, so when it says decay, that means you're subtracting. So the formula will only give you the growth rate, and then you need to remember, unlike me, oops, sorry, that was my cat. You need to remember that decay means you're getting smaller. So you're actually going to be subtracting the rate. So the formula for decay will be minus R, and then over here also will be minus the rate of 0.09. So one, oh man, 1 minus 0.09 is actually equal to 0.91. Okay, I gotta change this 2 and this 1. I am so sorry, please forgive me. 0.91, 0.91, 0.91, 0.91. Okay, so that's what we're gonna put in the calculator, the natural log of 0.91, and we get 8.033. So t equals 8.033. The only answer choice with that is the letter C. Again, you can also put this into NSolve, and I'll show you. Solve 15,000 equals 32,000 times 1 minus 0.09 to the power of x, comma, x, enter. You see, we get the same number. But you do need to be able to read the problem, figure out what value represents what variable, what formula are you using. So there's still a lot that is involved in the problem, so don't rely on NSolve to do everything for you. You need to put in the right information before you use NSolve. Okay, the number of downloads of a new song grows at a continuous exponential rate during the first week after the song's release, as shown in the table. Which function is used to find n of t, the number of downloads after t days? Okay, so the keyword here is continuous. So when it says continuous, you can look at your formula chart. And there are two equations for continuous, but they're literally almost the same thing. It's just A equals PERT, but the second one is just substituting A and P for N and N sub 0, but they mean the same thing. It's going to be your N value versus your initial value. But we can use the N one since this is not about compound interest, it's more about just exponential growth. So we'll use n equals n sub 0 times e to the power of kt. Okay, and this is a little 0 that's at the bottom. And then these are powers. Now it does just say n, but notice that on this table we have n of t. So just to match that, I'm gonna make the function. This is the same as f of x. Like literally it's the same thing. I don't want you to get confused. It's just the function name. Okay? So it's nothing weird. It's just different letters that they're using. Okay, so the n value after 5 days is 9,900. So that'll be my n of t. N of 0 is the initial value. So at 0 days, there were only 1,200 downloads. E is a constant number. Now we don't know what K is, but we do know it has been 5 days. Okay. Now looking at just what we have set up, we can eliminate some answer choices. So we do need an E because it is continuous, and only C and D have an E. So that means I can already immediately eliminate A and B. And then the only differences here are the K. So we're gonna figure out what K was, and that will determine which equation we're supposed to have. So algebraically, we're going to add or subtract, but there's nothing here, so we're gonna multiply or divide. So I can divide out the 1200. Okay, I can use my little trick from before. These zeros are gonna cancel out. So I have 99 over 12 equals E, and then K times 5 is just 5K. Now, to get rid of the E, because I need to bring the K down, I can multiply both sides by the natural log, because remember those two are related, and when you have them next to each other, you can cancel them out. So now we have the natural log of 99 over 12 is equal to 5K. And then divide by 5, and then put that in the calculator. Natural log of, what was it? 99 over 12 divided by 5. And to convert that to a decimal, you can go to menu and then number and approximate to fraction and then press enter. Oh, sorry, I meant approximate to a decimal. Convert to decimal. There we go. So it's 0.422. So K equals 0.422. And the only one that has that as the K is D as in dog. Okay, so let's say that you didn't know how to do it. You can use NSolve again. Another method you can actually also use is to plug in different values. So we have coordinate points here. We have 0 and 1200 and 5 and 9900. So what you could do is plug them into here and see if it gives you the result. So I'll try it with D because I know that that's the correct answer. So I'm gonna plug in for T, I'm gonna plug in the number of days and see if it gives me these Y values, okay? So that's 1200 times E to the power of 0.4220. And then the first day, it was 0 days. So I'm gonna put 0 for time. And it gives me 1200, which was the initial amount, so that's good. So now let's test the next coordinate point. So 1200 times E to the power of 0.422, and the next coordinate point, the value for T is 5 days. So I'm gonna do times 5. Did I mess something up? Maybe they just rounded it then. Yeah, they must have just rounded it to 9900, but the exact number is 9897. So it rounds up to 9900, depending on how you round. Now, to show you the difference, I can try this with the second option. That was the most likely to be the answer. Remember, A and B are completely wrong. The answer was between C and D. So we were to test the answer choice C with a different rate, which was, that answer choice said 5251. And if I try that with 0 days, the 1200 does match up, but when you plug in 5, you get 16,000. That is way off. So the most likely answer would be D as in dog. Okay, moving to the next problem. Which function is the inverse of f of x equals x over x minus 3? All right, so remember the first step is to switch f of x for y. After that, you're going to switch all of your x's and y's. This one has 2 x's, so both of them will be y's. To get rid of the fraction, you multiply both sides by y minus 3. You're going to want to distribute this. Actually, yes. X times y is xy, and then negative 3x equals y. So now what I want to do is get all the x's on the same side, all the y's on one side. I can add 3x on both sides. I have xy equals y plus 3x. But my y's are still on opposite sides of the equal sign. So now I want to move this y over here. So I have xy minus y equals 3x. So now on this side of the equals, I have all the y's. There are no more y's on this side, which is good. However, there's another x here, so we don't want that. We want to try to get rid of that because we only want y equals by itself. So let me rewrite this. If you remember from class, when we had a problem like this, we were going to use factoring. So this term has a y and this term has a y. So since the greatest common factor is a y, I can factor that out. And what you do is divide each term by whatever you're factoring out. So in this instance, y divided by y cancels out. You're left with x. And then on this side, they also cancel out, but it doesn't disappear. Remember that any number divided by itself is always 1. So this really becomes x minus 1 equals 3x. Now we're very close to get y by itself, but it's being multiplied by this factor. So to get rid of that, I can divide out the x minus 1. Okay, and then the last step is to switch y for the inverse of f of x. So the inverse is 3x over x minus 1, which is the letter C. Okay, so another method that you could use is to graph the original. Now this is a little bit tedious, but if you have no idea how to do any of these steps, you need to graph literally all of them. So let me show you. So you start with the original, x over x minus 3, and you're going to graph the first answer choice with it. So we're going to do, let's do A, answer choice A, x minus 3 over x. Okay, now these are both of the graphs. We're going to pull up the table. And remember that the x and the y values have to be switched. So the first table, we have 1 and negative 0.5. Now if the values were going to be switched, then you would not have a negative 2 here. Because the original point was 1 and negative 1/2. So the next point should have been negative, let's see. Let's find a better point. It's hard to see when they're all... Actually, let me just do one at a time because I'm actually confusing myself. Let me delete this. I want to get rid of the pink one. Okay, so now let's pull up the table. Oh, that pink thing is still there. I don't want the pink one showing. All right, there we go. So let's write down these coordinate points on our paper. So this is for the original table. So x, y, so started with 0, 0, 1, negative 0.5, 2, negative 2, 3 was undefined, and 4 is 4. So then what you need to do is figure out which table of the answer choices is going to have these reversed. So you need to find a table that's 0, negative 0.5, negative 2, and 4. Undefined is not going to be there, of course. And we're going to have 0, 1, 2, and 4. Okay, so now we're going to graph all of the answer choices and try to find that table. So we start with the first one, answer choice A, which is x minus 3 divided by x. Okay, let's pull up the table. So we're looking for 0, 0, negative 5. So 0, 0 is already not on there, so that's already out of the picture. Okay, so A is gone. So let's try letter B. So x divided by x minus 1. Pull up the table. 0, 0 is on there. The next point, we're not going to have the negative 0.5 because the graph goes by ones, but we can try to find the negative 2. So we should have the point negative 2, positive 2. And it's not. It's negative 2.667. So that would be incorrect. So B is not an answer choice. So now let's graph C, which is 3x divided by x minus 1. Pull up the table. So let's look for these points. The first one being 0, 0. Oops. That one is on there. We're going to skip the decimal. Let's go to negative 2, 2. Negative 2, 2. Yep, that's there. And then the last one was 4, positive 4, which is on there. So that's another way, if you don't know how to do it algebraically, just graph every single one of them and analyze the tables. Okay, let's keep going. Eric finds a bank that allows him to invest $2,500 at an annual rate of 4.5% compounded continuously. If there are no deposits or withdrawals, what is the account balance after 24 months? So that keyword compounded continuously. Let's go to the formula chart. We have compounded continuously, or continuous compound is A equals PERT. So let's write the equation. All right, so he's investing $2,500. That will be your initial amount P. And then the rate of 4.5, remember you move this over 2 places, so that's 0.045. We're looking for the account balance, so we're gonna set this equal to A, and then it says after 24 months. Now, they're gonna try to trick you and put this in months, but we know that it has to be in years. So how many years are there in 24 months? The answer would be 2, because every year has 12 months. So in 2 years, there will be 24 months. So you're going to multiply by 2. Okay, so they try to trick you because they gave you the answer if you had plugged in 24, but that would be incorrect. So now let's just put this straight into the calculator. 2,500 times E, 0.045 times 2. Enter. 27.35 with 44 cents, which is the letter C. Okay, so very important that you know which formula that you're using, and also to convert any months, or they give you, you know, days, or I don't know, something weird, like it has to be in years. Okay, let's keep going. A house with an initial value of $125,000 increases at a rate of 4% per year. Approximately how many years will it take for the value of the house to reach $225,000? Okay, so this is another type of exponential growth problem. It says that it's increasing at a rate of 4% per year. And approximately how many years will it take? Okay, so what we can use is we can use either one of these formulas. I know they look different. Notice how this problem doesn't say you know, compounded quarterly. It doesn't say quarterly. It doesn't say monthly. It doesn't say yearly. It doesn't say daily. So if it doesn't give you a compounding period, technically it's not this one, because the compounding interest is going to have a compounding period. If it doesn't give you one, that means that the compounding period is annual. Okay, so if it doesn't say quarterly, monthly, daily, then you have to assume that it will be once a year. Okay, now if I plug 1 in here and here for the n, so because n equals 1 for yearly, right? R divided by 1 is still R. So notice that's the R that's at the bottom. And 1 times t is still t, which is the t that's here. So technically, if n is 1, these two formulas are the same. So you can use either of them, okay? I think you guys are most comfortable with this one, but I'm going to use this one just to show you how it works, okay? So we have n equals n sub 0, 1 plus r times t. Let me make sure I wrote that right. Okay, so again, n sub 0, anything with the subscript of 0 is your initial amount. So the initial house, so the value of the house was $125,000. 1 plus the rate of 4%, convert that as a decimal, that's 0.04. Also remember last time I messed up and I put a plus instead of a minus. This one is actually going to be a plus because it says increasing. So the other one said decrease, so I put a minus. When it says increase, you're going to put a plus, okay? How many years will it take? So t is unknown for the value of the house to reach $225,000, okay? Start by adding or subtracting. We can add 1 plus 0.04. That's 1.04. Then we're going to divide out 125,000. Okay. This cancels out. Now this is a pretty big fraction. We could do our little trick where we just cancel out all of the zeros. But I do think it's going to reduce to a smaller fraction. So we can simplify that. Oops, too many twos. 225 divided by 125,000. So it reduces to 9/5. So let's keep going. 9/5 is equal to 1.04 t. Now remember, to get the t down from the exponent, you're going to take the natural log of both sides, which will bring the x to the front. So we're going to have the natural log of 9/5 equals t times the natural log of this. To get t by itself, we're going to divide this out on both sides. So let's put this in the calculator. Natural log of 9/5 divided by the natural log of 1.04. We get 14.9866. So t is 14.9866. Let's look at our answer choices. So this will round up. So then, it becomes 99, and then 14.99 is basically 15. So the correct answer is 15 years. You can also put this in NSolve, but you do need to know what formula to use, and you need to know how to set up the formula. So you need to make sure everything is getting plugged in where it's supposed to. Okay, let's keep going. The Richter scale can be used to calculate the intensity of an earthquake based on the amount of observation motion. If A is the amplitude of the observed motion in micrometers, this is just the abbreviation for micrometers. So it's kind of like how inches is just IN and how centimeters is CM. Micrometers is this Greek letter mu, meters. Okay, so I know it looks scary, but that literally doesn't even have anything to do with the problem. Then certain earthquakes Richter scale measurements can be calculated using the formula R equals 3.75 plus log A. What is the amplitude A of an earthquake that measures 5.75 on the Richter scale to the nearest micrometers? Okay, so it's telling us that we're trying to solve A. Okay, so what is the amplitude A? So then by default, this other this other number has to be r because there are only two unknown variables in the question. So let's go ahead and plug everything in. 5.75 equals 3.75 plus log of a. Okay, use PEMDAS upside down. We can subtract this 3.75. That becomes 2 of log a. Remember, we can convert this to an exponential. If it helps you to have the number on the right, you can rewrite it like this. And if the base is not there, you can put a little 10 to help you. Because if it doesn't have a base already, it's going to be a base of 10. So you're going to do your loop-de-loop, convert this. So you have 10 squared equals a, and 10 squared is 100. Okay, so the final answer is 100. If you can set it up, then you can put this into NSOLVE. Let's go to the next problem. Give me a second to drink some water. I just realized that gulping sound is probably really loud on the video. I'm sorry. Okay, an exponential function is shown. F of x equals 5 times e to the power of negative x. What is the domain and range for this function? So let's go ahead and graph this. Okay, so this is what the graph looks like. Now, if you want to zoom out, you do menu zoom and then zoom out, and you can keep going on this. And domain is read from left to right. So I can see if I can keep going, and this graph is just going to keep going. So it's going infinitely to the left, and you can see it's going infinitely to the right. So the domain has to be negative infinity to positive infinity. So already I can eliminate B and C. Let me just sketch this graph for you actually. What did it look like again? Oops, wrong app again. Okay. So it looked kind of something like this. Right? Right. Okay, so you can see it goes forever to the left and forever to the right. So that'll be all real numbers. So the domain has to be negative infinity to positive infinity. So we eliminated B and C. The differences in the range are a parentheses versus a bracket. Okay, bracket is used when you are touching something, when it is included. So as you can see, the graph has a horizontal asymptote at y equals 0. And if you look on the calculator as well, you can see that the graph actually, I mean, it looks like it's touching, but it's just getting really, really, really close to it. And notice that it never goes underneath that. If it doesn't go underneath that, then that means it's like constantly just hovering on top of the x-axis. So because there's a horizontal asymptote, we're not going to use a bracket. Okay, we're going to use a parentheses because you're never equal to the asymptote. So the correct answer is A. Okay, what is the inverse of f of x equals 2x over 3x minus 1? Okay, so let's repeat our steps from before. The first step is to change f of x to be y. Multiply the denominator. Oops, I'm ahead of myself. First, I have to switch my x and y values. Then I'm going to multiply the denominator on both sides so I can get rid of the fraction. At this step, I can distribute this x into this binomial. So that would be 2xy minus x equals 2y. I can add this x over here. But I want the y values on the same side. Right now they're on opposite sides, so my next step will be to subtract this 2y. So now I have 2xy minus 2y equals x. So now we're going to factor out the greatest common factor. Technically, the greatest common factor is a 2y because it has a 2y here and a 2y there. But your final answer should only be y equals. So even though you can factor out a 2, you do not want to do that because all you want is y. So let's only factor out a y. So if I divide this term by y, then these y's cancel out. And if I divide this term by y, then these y's cancel out. So we're left with 2x minus 2 is equal to x. Okay, let me write this again so we can do the next step. Now y is being multiplied by a binomial, so I'm going to divide out the binomial on both sides. And that way these cancel out. And then the last step is to switch y for the inverse of f of x, which equals x over 2x minus 2. Oh man, how did I end up with a 3 in there? I mean, a 2. Oh my gosh, I messed up the problem. All of these had to be 3s. I can't believe I did this. That's okay, I'll fix it. I hope you weren't writing in pen. You know I don't like you writing in pen. No, I'm just kidding. I'm sorry though. Okay, so it was 3y, 3y, 3xy, 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 3x, 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 and 3x. Okay, sorry. So the final answer is x over 3x minus 2, which matches with the letter D. Now you're probably wondering what is all of this stuff. These are rational functions, so remember that the denominator cannot be 0. So basically if you were to solve this, the denominator for 0, you would get 3x equals 2, and then divide, you would get 2/3. So this is where the vertical asymptote is, and remember you don't ever equal the vertical asymptote, so they're just telling you a domain restriction on the inverse, and they did that for all of them. So if you set the denominators, you don't really need that. They're just kind of being extra with it. I mean, technically it is mathematically right, but yes, so this is how you do it. You can do the method that I showed you last time, where you graph this one, write down your tables, figure out whatever y values, and then figure out which one of these has those x and y values interchanged. So you can use that method as well. Number 13, the number of computers infected by a virus is modeled by the function c of d equals 6.8 plus 20.1 times the natural log of d, where d is the number of days since the first computer was infected. Approximately how many days will it take for the number of infected computers to reach 60? Okay, so now c of d, again, that is just a function. So it's like f of x. D is the variable that is in the equation, but the actual function name is c. So c stands for the number of computers infected by a virus. So it says the number of infected computers will reach 60. So that means that c of d will be 60. And the question wants to know how many days will that take, okay? Approximately how many days. So we're going to use PEMDAS upside down, starting with adding and subtracting. We can subtract 6.8. 60 minus 6.8. 53.2. Now before you get into that natural log, you do have to divide out that coefficient of a 20.1. This cancels out. Now, I could try to simplify that fraction, but that's not really that important right now. So I have the natural log of d. I can't just divide out the natural log and leave the d. Like, they are attached. They cannot come apart. The only way you can get rid of that natural log is if you multiply both sides. If you raise both sides to the power of e, because then e cancels out the natural log. And so we have e. And whenever you take e, whatever is in parentheses will become the exponent of e. And so this will be equal to d. So we're going to go and put this in the calculator. And we get 14.108. Let's say you didn't know how to do it, but you could at least figure out that the number of computers was 60. You can use your NSolve menu, algebra, and then NSolve, type in the equation, and we're gonna get the same thing. But just change D for the letter X. You get the same value, 14.108. So approximately that would be the letter B as in boy. Okay, 14. Paul invests $1,250 in an account with a 3.25% interest rate. If Paul makes no deposits or withdrawals and the interest is compounded daily, what will the account balance be after 2 years? So this is, it has a compounding period of, it's daily. But if it has a compounding period, then that means it is not continuous. That means that we're going to be using the compound interest formula, which is this one here. So let's go back and write it. So that's A equals P1 plus R over N to the power of N times T. Okay, so he invests money, that's your principal amount, with an account with a 3.25% interest rate. Convert that to a decimal. Move the decimal place 2 places to the left. And compounded daily, there are 365 days. That represents the letter N. Okay, to the power of N times 2 years will be time. Okay, and we're trying to figure out A. So thankfully this one is easy. You can just type it into the calculator. So 1250 times 1 plus 0.0325 over 365 to the power of 365 times 2. We get 1333.94. My numbers are getting uglier by the second, I'm sorry. So the answer is A as in apple. Okay, let's go to the last problem of the test. Which graph represents the inverse of the function f of x equals 5 over the square root of x minus 2? Okay, so we're going to switch f of x for y. Then we're going to switch our x and y's. And then we're going to solve for y. Now, the first thing you want to do is get rid of that fraction. So we're going to multiply the denominator on both sides. So this cancels out. You cannot distribute this like we did in the previous problems, because this whole thing has a square root on it. But thankfully we don't have to do that anyways. So we have the square root of y minus 2 times x is equal to 5. So I can actually just go ahead and divide out the x, which makes it pretty easy. So these cancel out. We're left with the square root of y minus 2 over 5 over x. To get rid of the square, so remember there's an imaginary 2 here that's not written because the square root is the most common. Now if it was a cube root, a fourth root, fifth root, like if it was any other number, it'll be more explicitly written, but the 2, it's not really there. But anyways, I'm getting into this long tangent. Basically just know that the square root cancels out a square, and a square cancels out the square root. So if you have a square root, you can square both sides, and that cancels that out. So you have y minus 2. And make sure when you take the square on the other side, you put everything in parentheses. Okay? And now the last step will be to add 2. Actually, the last step is to replace this y for the inverse of f of x. Okay, so let's go ahead and graph this in the calculator. 5 graph parentheses fraction 5 over x to the power of 2 plus 2. Okay, so we get 2 halves of the problem, and if you notice, none of I keep opening the wrong tab. None of our answer choices have 2 sides of a graph, like it's only one side. The reason for that is because in the denominator, they gave you the positive square root. So remember, you can either have the positive or negative square root of something. But here, they gave you the positive square root, meaning that the domain is going to be positive. So if they gave you the positive square root, then your domain will be from 0 to infinity, and it's included. So we need to figure out, we can eliminate some answer choices, because the range, so remember the domain and the range switch. So we're only going to be interested in the positive range values. So if this is a domain for the inverse, well, that's not really the domain. That's just the domain of the denominator. We can graph the whole function and get the whole. Let me be more precise with my range. 5 over the square root of x minus 2. Oops, I forgot the x. Okay. So you can see that it is, okay, it doesn't actually touch 0. It's an asymptote. So it's parentheses 0 to infinity. So let me get rid of the bracket. So it's 0 to infinity. So that means that if the original domain is that means the inverse range will be 0 to infinity. Because remember, the domain and the range switch. And then so let's see what the original range was. Let's go back to the original graph. So you can see that it is 0 to infinity. So there's a horizontal asymptote, so it just keeps getting closer and closer, and then it goes on forever. So the range, sorry, keep opening the wrong things, is also 0 to infinity. So our domain for this one will be 0 to infinity. So let's find a graph that has that domain and range. So we can eliminate B, we can eliminate C, and we can eliminate D actually. So by default, the correct answer has to be A. And so basically what's happening, let me go back to the previous graph. So this was the one that we had calculated as the inverse, 5 over x squared plus 2. So basically, because the original one was only 0 to infinity, even though there is this left-hand side, they're only focusing on the positive side. So that's why the answer only looks like the right-hand side of the graph. Another thing that you can do is what I showed you last time, where you pull up the table of the original one and then try to find coordinate points on the graph to see which one has the x and y values switched around. But yes, so I hope this helped you a little bit more, how to solve inverses, exponentials, and logarithms. And let me know if you have any questions, and I will see you in the next video. Bye.